Okay, now we will consider another an extension of the previous model, toy model number 2. Uh, in this model, we introduce an exogenous variable x and say y1 is determined by y2 and x, y2 is determined by y1 and x. So, and as usual, the exogenous variable has zero correlation with epsilon1 and epsilon2, right? So there are four different components in this system of equations: endogenous variable, exogenous variable, parameters, errors. And as before, so the problem here is y2 affects y1, then y1 affects y2. So they are going back and forth, and it's a reverse causality problem here. And then you want to determine y1 and y2. They are endogenous variables. And simple. Solve these equations for y1 and y2. So then as a result, you will get this. I believe you know how to do this. And then as you see, y1 is a function of exogenous variable and error terms and other parameters. Similar, endogenous variable is determined by these guys, right? So like y1 is not determined by another endogenous variable. Endogenous, the equilibrium in the equilibrium must be expressed only in terms of these guys, not the endogenous variables. So in the model, the endogenous variables are just a result, not given input. So, uh, so in the reduced form equations, the output is written as a function of inputs. So that is the key idea. And now, and usually, so it's simply in the end, as you can see, it's a function. Y1 is a function of x, and this is a complicated form of parameters. So like multiply and add and divide by parameters, and the second term is just error term. So epsilon1 plus epsilon2 multiply by something, but in the end, as a whole, it is another error term. So we are going to rewrite the reduced form equations in this way. y1 is some parameter, something times something x plus some error. So the parameter pi1 is this guy, and u1, new error term, is this guy. And our approach here is that I defined here. So then from the reduced form equations, it is clear that you can identify pi1 because you can regress y1 on x. X is exogenous. So x is uncorrelated with u1, which is easy to show. So x satisfies the classical linear regression model assumptions. So pi1 is estimated by the OLS method, which is pretty simple. So pi1 is identified. Pi2 is also identified by the same logic. So then the remaining question is, okay, we know what is pi1 and pi2. Then we know this and we know this. Then from there, can we recover beta 1, gamma 1, beta 2, gamma 2? Of course not. So that this will be the main problem in the simultaneous equations model from now on. So we estimating the reduced form equations is not a problem at all. But the real problem is converting the estimation results from the reduced form equations into the parameters of structural form equations. And then And then simply it is not possible because you only have two information, pi 1, pi 2, 2 degrees of freedom, but you have to determine 4 parameters. Not possible. Simply, it's not possible. And you may approach this to this uh, result conclusion in different ways. Another way you can think about here is the moment condition approach, which I recommend because it is the most general and maybe most intuitive when the model becomes more complicated. So simply remember, the moment conditions we have is the exogeneity in x, which means uncorrelatedness between x and epsilon 1 and x and epsilon 2. So two moment conditions, and replace epsilon 1 with observed variables and the parameters. Then you have two moment conditions. But already it's obvious that you only have two equations, 4 parameters. End of the story. There is nothing you can do. It cannot be solved. Another approach here is IV approach. So you may think about the instrument for the endogenous variable. So in the first equation of the structural form, y1 is a function of y2 and x. Here the problem is endogeneity in y2. So you can identify gamma and beta if you can find an instrument for y2. But let's go back to the determination of y2. So excuse me. Here, the structural form. So y1, the problem in the first equation is the endogeneity in y2. Then now let's think about the excluded instrument for y2. Then you have to think about how y2 is determined. But y2 is determined only by y1 and x. y1 cannot be an instrument because it is already a dependent variable. And x cannot be an instrument because it is already included in the regression. So in the end, there is no instrument available. There is no instrument available here. Therefore, nothing you can identify. So that is another way to argue. By the way, it is so when you claim that something is not identified, actually that is more difficult because so like for example, showing that you are doing something wrong is so like say excuse me, put it this way. So like when I have a question, if you understand the material, writing the correct answer is easier than writing a wrong answer. And like especially when you write a wrong answer, it's really hard for me to explain what is wrong because it's clear that you are wrong, but it takes a lot of time to explain why you are wrong. So similar, it's I'm just explaining more intuitive way, but later when you see identified model, then you will see the difference. So if there is something unclear, please wait a few more videos, maybe in the next lecture. Maybe today I think I cannot show you any identification result. Finally, any possibility of identification if you can reduce the number of parameters to 2. So the main problem here was you have two equations, two moment conditions, but 4 parameters. Then if you can add 2 restrictions on the parameters, and if you can reduce the number of parameters to 2, then there is some hope. That's also intuitive. Like for example, you may assume that beta 1 is a specific number, beta 2 is a specific number, or you may restrict something equals to another, or like this. So any restriction will help, and you need 2 of them. So that's that's another simple conclusion we can learn from this case. And okay, I will continue in the next video. I'll call it a video. So see you later.